Alright guys, now we are going to discuss question number 2 and 3. A kangaroo is capable of jumping to a height of 4 meters. You're asked to determine the takeoff speed of the kangaroo, and hint is velocity at the maximum height is equal to 0. So let's first visualize the problem. So kangaroo is definitely going to start from maybe a ground level. So it starts at a bottom level and then it's going to jump up, okay, and then it will come back eventually to the same height level. But what we are really interested in is about starting point to the maximum height. So I'm going to label that as initial point and then final point, just to make sure you guys know which 2 points I'm talking about. So I'm going to take the y0 initial position as 0. Why? Because remember I said I always take the bottom level as the 0, the ground level. It starts at ground level and it jumps up to 4 meters above ground. So the final y position, the y is equal to 4 meters. Final y position, okay? And the acceleration, in this case, this is also a free fall problem. So whenever we talk about a free fall problem, we know that the acceleration ay is equal to negative 9.8 meters per second squared. Why? Because we take up as positive y. So we also know that when the kangaroo is at the maximum height, because it has a capacity to jump up to 4 meters. So that's the maximum height it can reach. At that point, its velocity Vy is equal to 0, final y velocity. We are asked to find out the takeoff speed. That is the initial y velocity V0y, takeoff speed. At what speed does the kangaroo start its motion? So now we have everything here. Now we need to decide the correct equation. So oftentimes I have heard students telling me that's the most critical part, choosing the correct equation. Well, I tell you it's not hard as long as you have a clear diagram. Now, let's assume I have no idea which equation to use. If that is the case, I'm going to just come here and write down the first kinematic equation from the 4 equations we have for the y-axis. And then I'm going to put a tick mark for the ones that I know, and then I'm going to put a question mark for the ones that I don't know. So final y velocity, I know that's equal to 0 because that's the maximum height. Initial y velocity, I don't know yet. And I also know the acceleration, negative 9.8. And I have no idea what time is. So I have 2 unknowns. What did you learn in algebra class? If you have 2 unknowns, you need to have more than one equation to solve for it. So this equation does not help us. I'm going to cross it out. And then I'm going to write down the second equation. And in this equation, I'm going to do the same thing, put a tick mark for the ones that I know, and a question mark for the ones I don't know. I know final y position 4 meters. I know initial y position 0. I don't know the initial velocity. And I also don't know the time. So I'm not even going to bother about the remaining terms because I have 2 unknowns. It's not going to help me. I'm going to cross it. And I have the third equation now. I'm going to write down the third equation. V squared Vy squared is equal to V0 y squared plus 2 times acceleration y minus y0. Do we know the final y velocity? Yes, it's 0. Do we know the initial y? No. Do I know the acceleration? Yes. Do I know the final y position? Yes, 4 meters. Initial y is 0. So there's only one unknown, that's initial y velocity. Can we use this to solve for initial y? Of course, yes. So I'm going to substitute final y is 0 when the kangaroo is at the maximum height. So guys, just keep in your mind, you can choose any point in the path as the final point. I'm going to choose the maximum height as the final point because I have more data if I choose that as my final point. Final y velocity is 0, initial y I don't know yet, plus 2 times acceleration negative 9.8 meters per second squared. Final y position 4 meters, initial is 0. So now it is for you to solve for it, but I'll do it here. So 0 is equal to v naught y squared plus 2 times negative 9.8 times 4. We should get negative 78.4. So I'm going to write negative 78.4 meters squared divided by second squared. And if you divide both sides, not divide, pardon me, if you add 78.4 to both sides of the equation, you can write 78.4 because our objective is to separate v naught y on one side plus 78.4 meters per meter squared second squared. You can cancel these two and you get v naught y squared is equal to 78.4, and v naught y is simply equal to square root of 78.4 meters squared divided by second squared. So if you take the square root of that, you will get 8.85 meters per second. Initial y velocity is positive. I'm going to accept the positive answer because when you take the square root of something, you can accept either the positive answer or negative answer. I'm going to accept the positive value because if you look at the initial velocity, it's going up. The kangaroo is initially going up, so it has the initial velocity that is pointed upwards. Okay. Alrighty, so that's question number 2. Now let's do question number 3. In this one, an object is dropped on Earth from a height of 1.50 meters. Determine the time for the object to fall to the surface of the Earth. And I give you a hint as well. Initial velocity of an object that is being dropped is equal to 0. So let's see how we can start the problem. As always we do, we need to start with a diagram. So I'm going to, let's assume you are on the top of a cliff and you drop the object starting from this point. So this is your y naught. Initial position is 1.50 meters. And then your final y position is equal to 0 because it reached the ground level. And if you draw a motion diagram to make things clear, you can say it's speeding up. And acceleration ay is always negative 9.8 meters per second squared. And we take up as positive y. And initial y velocity v naught y is equal to 0. Final y velocity we don't know yet, and we also don't know the time t, and we are asked to solve for the time. Okay, so that's what we are trying to solve for. Now let's assume I have no idea what equation I should use because this is the information. This is how you would visualize the problem. Now since I'm solving for time, I'm going to just write down my first equation. Vy is equal to v naught y plus acceleration times time. And I don't know the final y velocity. I do know the initial It's 0 because you just dropped the object. Acceleration negative 9.8. I don't know the time. What did I say? If you have two unknowns, don't choose that equation. So I'm going to cross it out. Let's write down the second equation now. We have y is equal to y naught plus v naught yt plus half a yt squared. I do know the final y position. It's 0 because it reached the ground. And initial y position is equal to 1.5 meters. Initial velocity is 0. Time is an unknown. Acceleration is a known. Time is an unknown. So only unknown is time. Okay. Yes, it does appear in two places on the equation, but it is just one symbol, t. T is the only unknown. So I can use this equation to solve for time. Okay. So let's do the substitution. Final y position is 0. Initial is 1.50 meters plus initial velocity 0 plus half times negative 9.8 meters per second squared times t squared. Now if I solve for if I solve for time, I need to make sure I separate it. So I have to subtract 1.5 from both sides. And when I do that, this is what I get. And I'm going to write negative 1.50 meters is equal to negative. So you can solve this, simplify this, negative 4.9 meters per second squared times t squared. And then you can divide both sides by negative 4.9. And you can cancel out. And for time, you get t is equal to the square root of 1.50 meters divided by 4.9 meters per second squared. You can see you have negative on the top and the bottom. It will cancel out. We solve for this. Square root of 1.5. You get 0.55 seconds. I accept the positive answer because time is a scalar quantity. It can never be a negative value. So that's it for question 3.